Now let's also talk about how and on which kind of data set these LLMs are generally trained on. So as you can see, um, if you talk about the GPT-3, which was trained on 300 billion token. Now again, we are not able to still understand what are the tokens, but you can consider for now that one token is equal to one word. However, it's little bit more difficult than that, but just for now you can consider one token equal to one word. So therefore you can conclude that 300 billion token means 300 words, which is being used to train the model like GPT-3, which was released in 2020. So you can assume that right now we are in 2026, and the billions of tokens which is used in order to train a model like GPT 5.5 or maybe Anthropic model is gonna be much more than that, right? Now here don't confuse by the billions of tokens and the billions of parameter. Both are different things. Parameters are different thing, tokens are different thing. So tokens is very similar to words. 3 billion tokens means 3 billion words, and when I say 3 billion 300 billion parameters, so parameters means these are the values which model will gonna learn inside the entire LLM, right? So whenever if anyone say parameter, so you can always go ahead and remember the equation y equal to mx plus c, where you will be able to get the idea. Okay, uh, in the y equal to mx plus c equation, we have m and c are the parameters. So similarly in the large language model we will have the similar kind of parameter, but in billions, right? Not just two parameters. All right. Now these are the three different data sources were used to train the model like GPT-3. Now you may ask, like, why we are talking about GPT-3? See, the training data will increase, but you just have to understand the common pattern. Okay, if you will be able to understand the type of data which is being used in GPT-3, the similar kind of data is being used in order to train other models as well. So we have something called as common crawl dataset, then web text 2 dataset, and books and Wikipedia dataset. Now these data sets are also available in public. Let me show you. So if you go to Google and just search common crawl dataset, common crawl dataset. So you see this is the website, and it's free and open source repository for the web. You see, and it has over 300 billion pages spanning 19 years. So this particular website is collecting all the data from last 19 years, and ChatGPT 3 has used this same kind of data, which called as common crawl data, and in their entire corpus 60% was data was from the common crawl data set. Then we have something called as web text 2 dataset, which is 22% of their entire corpus, and this is also publicly available. You just have to search web text 2. So web text 2 dataset, and this is the first link. You see, yeah, this is the link. You will be able to see 65.8 GB uncompressed dataset, 28 GB compressed including text and metadata, right? So they have used this dataset also, which is again publicly available. And then they have used some kind of books and Wikipedia articles for their remaining 18% of the dataset. Now if you understand the nuances and physics and cost of pre-training, so it's a very huge. Okay, so GPT-3 actually it uses first of all 96 transformer layers in it. Remember, LLMs, we have talked about the architecture of the LLM. So we know that LLM only uses this decoder block, right? We in the transformer we have encoder and decoder, but if you talk about GPT, so GPT also uses this decoder block only. So if you go and talk about this GPT-3, so GPT-3 uses 96 such kind of decoder block, but in general we call that as a transformer layers. Okay, because in the decoder block also some kind of transformation happens. So in general we call it as a transformer block, but specifically if we talk about GPT, so it is using the decoder block and 96 such decoder block. Okay, and it also has 175 billion total weights. So parameters, parameters are also called as weights and biases. So GPT has this 175 billion parameter weights and biases. Then the total compute cost was around 4.6 million dollars, right? Which is a very huge cost, and because these giant models we need to train on for number of days and number of days, and like everybody can't afford this much amount, right? And that's why it is not possible to train these kind of big giant models by each and every organization, right? So of course, OpenAI has the funding, and based upon that they were able to do this computation, and they were able to come up with this kind of model.